we go. Sorry, the boys are still asleep. So I think I have the numbers right. Marie, I can't tell exactly that worksheet. It isn't your fault. It's not the picture. It's the copy of the paper. So Kaden did this one already, but when you have a point outside of the circle and the lines are tangent to the circle at a point, then these two sides are equal to each other. So you set 3x minus 6 equal to the other piece, x plus 10, and then you solve for x, which he did that one. That one's good. Number 2 wants the perimeter of the triangle. So the same piece, the same theorem applies. So we have this angle Q out here. It's tangent. The lines are tangent. So if this is a 4, this has to be a 4. If this is a 9, this has to be a 9. If this is a 13, this has to be a 13. And then you just add all of those together. Okay, I know I skipped number 3, but I think he can do it knowing that theorem. Okay, this one is the one I'm not sure if I have the numbers labeled right on the picture, but let's give it a try anyway. So it wants a bunch of stuff. It wants the measure of arc GE. So GE would be this arc out here. So that arc is going to measure the exact same as that angle. I don't remember if they gave us that angle. I didn't write it on here. I'm going to have to come back to that one. But if whatever that angle is, that arc is the same because that's called a central angle or center angle, and that's a central arc. So they're the same. I've got to look that back up. All right, the measure of HNE. H is right here, and E, oh, I need to find that too. Oh, let's see. Sorry, I'm doing this as I go. They did give us this arc is 120, so I think we can work backwards. If this arc is 120, and they told us that this was perpendicular to this, so these two pieces have to be the same amount. So if this is 120, then it has to break it into 60 and 60. So now we have the measure of arc GE. That has to be 60. That means the angle that it is used to cut it off like a piece of the pie, that is also 60. And then it asks for angle HEN. Let's see, sorry, HEN. Let me think about that for a second. Oh, so if this is 90, because it was a right angle, because that was perpendicular, if that's 90 and that's 60, this piece has to be 30 because altogether they're 180, or if that's 90, these two have to be 90. So if that's 60, this has to be 30 degrees. And then the last one wants HN. So H to N is this piece right here. Now they told us in the picture that the radius is 18. So if this is 18, this is 18. Let me think about this for a second. Over here they told us something was 9. It must have been this piece was 9. Like there's a couple different ways to get this. I just don't know what Kaden has learned already. So if we want HN, this piece, we can use the 30, 60, 90 triangle information. So that would be across from the 30, this would be A, across from the right angle it'd be 2A, and across from the 60 degree would be A squared of 3. So that's what I'm going to use. Since we know across from the right angle is 2A, that means A has to equal 9. And if the side across from the 60 degree angle is in the proportion A squared of 3, then it has to be 9 squared of 3. I believe that's what they're trying to get at. You could also use a trig function like sine, cosine, or tangent to get that.